The capacitor start motor has the running coil connected directly to the supply, live over there, and neutral over there. The start coil, on the other hand, connects like we had previously, but now we have a capacitor connected in series with that inductor, and then finally we have a centrifugal switch connected onto that series circuit. Now the effect that this will have, this running coil will have a small internal resistance, and it will have a large inductive reactance. So the effect that it has on the phase shift between the voltage and the current will be very great. If you think back to RLC circuits, that would represent the voltage angle, and then this would represent the current angle. Now that has to be black. Current angle for my running coil. My starting coil, on the other hand, we see that this whole circuit consists of the internal resistance of the coil, which is very small. We've got a large inductance, but we also have the capacitance. So the result is that the phase shift on the voltage and the current is more in this direction. The result is, if we look and we see this voltage and that voltage is equal, because it's the same supply voltage, and if we scale it and draw it, we're going to see that this is the supply voltage, which is red, and this is the current. Now let's quickly look at that. We see that we've got approximately 64 degrees there. So there we've got about 64 degrees, which means we're about there. So that is the current flow through the black phase, or through the running coil. On the starting coil, we've got about 40 degrees. Which means our phase shift in the current looks to be at roughly just more than 90 degrees in this example. Now the function of the centrifugal switch, because I've got this big phase shift, there's a lot of torque, and as a result we will generate a lot of speed very quickly. Now the centrifugal switch's purpose is that switch is mounted directly on the axis of the motor, and when the motor reaches its running speed, it will open that switch up, which disconnects the starting circuit, which means only the running circuit is still maintaining the rotation. So what happens is we're drawing a lot of current, because we've got a parallel circuit, we're drawing a lot of current flow, and then the moment the motor reaches the operating velocity, then the starting circuit disconnects and only the running circuit maintains. The motor will slow down over a period of time, and once it slows down sufficiently, the centrifugal switch closes again, and that causes the phase shift in the starting circuit to allow for the speed up of rotation again, and that way the motor's speed remains pretty constant, and it also saves power by removing the start when the motor is at running speed. So the function of the components, we've got our main stator windings, the start and the running winding, and then the capacitor is there to increase the phase angle between the running circuit and the starting circuit. This motor will be connected directly to a direct online starter in the same way as we would have, like we've looked at previously. If we look, and we've got our live, then we've got our overload, our stop, and all our other protective devices. Here's my start, that connects to my contactor, which connects there to neutral. That contactor has a latching contact. That's the overload, that's the stop, start, MC1, MC1. Normally open. Now we will have our overload and our main contactor, which will then connect to the running coil, to neutral, and there we will have the starting coil, the capacitor, the centrifugal switch, which then also connects to neutral, and that's typically how we would connect our motor up.